So I want to say a few words about Bjørn Ekeberg's book, Metaphysical Experiments. We read the first couple of chapters, the introduction and the first two chapters from his book. And you'll have noticed by now that he's offering a sustained critique of the hidden metaphysics of contemporary physical cosmology, nuclear physics and astrophysics in particular. And he does a bit of historical excavation to uncover this metaphysical core that he sees at the sort of the hidden heart of contemporary physical science. And he points out that originally, when the scientific revolution was getting underway, there were clear theological motivations here, right? This is more well known with Newton, but even, Galileo was imagining mathematics as the kind of the language of nature because nature was divinely designed so as to have these mathematical harmonies implanted within it. I mean, and this is a very, very old idea that goes back to the ancient world and this Pythagorean intuition that number is somehow right at the very core of reality. And so these early modern scientists were inspired by a certain kind of Christian theology, which gave them these metaphysical ideals of unity, for example, the unity of nature, the unity in particular of our mathematical understanding of nature. And so they had a faith in this unity of nature and in the principle of sufficient reason, that everything has a cause. Everything happens for a reason, right? Because the universe is designed by God. And so without this theological motivation, and Ekeberg's not the only one to point this out. Whitehead points it out in his own way as well. Without this theological motivation, modern science, in its mathematical and mechanistic orientation, in an attempt to master nature, it never really would have gotten off the ground. And so, Ekeberg will talk about interest, and it's a concept we'll return to later in Whitehead's book, Modes of Thought. In interest, right? Scientists like to say that they're disinterested. They're pursuing truth for its own sake, right? And they're not motivated by religious beliefs. They're not motivated by politics or economics or profit. They're motivated just by the truth. But Ekeberg and the thinkers that he's drawing upon and inspired by, like Bruno Latour, the sociologist of science, and Isabel Stengers, the philosopher of science, both of whom were also influenced by Whitehead. They've made their careers. Stengers is still writing. Bruno Latour passed away last year. They've made their careers, though, turning a sociological lens onto science and a metaphysical lens onto science to point out the ways that the way scientists talk about the knowledge they produce is not actually how they produce that knowledge in practice, right? So Latour would follow scientists in the laboratory, kind of like an anthropologist studying a foreign exotic culture. And he did this kind of anthropology of modern science and pointed out these vast extra scientific networks of instruments and funding and all sorts of other agents that need to conspire in order for what we call a scientific fact to be produced reliably and robustly. And so, Latour in particular was accused in the 90s during what was called the science wars at that time between the hard-nosed scientific realists and the so-called social constructionists. Latour was accused of not believing in reality, right? Because, when he analyzed the history of science as a sociologist, he would say when Pasteur discovered pasteurization, that microbes like yeast were required to ferment foods and alcohol. It was Latour says, as though something new was brought into the universe, not just knowledge, but a new kind of existing being, right? Not so much that the microorganisms were conjured into existence by, Pasteur's experiments, but that until human beings became aware of this entity, these entities, this whole universe of beings, of microorganisms, they weren't part of our world. And, science is obviously in the business of expanding our conception of the world, but Latour wants to make this point that as science engages in its quest for knowledge, it's not just observing something that's out there separate from us. Science is not just knowing about the world, but it's transforming the world, right? Every act of knowledge is a transformation of data, measurements, into a kind of fact, and a fact presupposes a theory in terms of which it can be situated among other facts. And so, this sort of sociology of science from Latour and Stenger's use of Whitehead and others like Gilles Deleuze, the French philosopher, to look at the metaphysical underbelly of contemporary science. This is all in the background for Ekeberg. And he's obviously very critical, right, of this whole project of modern physics. And he doesn't offer us much in the way of reconstruction. But I thought pairing his book with Whitehead was ideal, because it's as though Ekeberg's kind of clearing the slate and preparing us for Whitehead's alternative process relational approach to natural science, to physics, to biology, to cosmology. There are certain hints that Ekeberg gives us, though he never mentions Whitehead, but he gives us these hints that process, that relationality, interconnection, that these are the sorts of concepts that we would want to rebuild science around. And indeed, in so many ways, quantum physics is already built around these ideas. It's just that many quantum physicists are hesitant to do philosophy and to talk about what the math means. But Whitehead helps us talk about what the math might mean. So, yeah, I thought this was an ideal book to pair. So Ekeberg wants to make very clear to us in, doing kind of what Latour did, a kind of anthropology of science, where he looks at how the facts are made inside of a team of scientists working at a particular group of scientists working at the Large Hadron Collider. And he studies how, with this array of dozens of computer screens and server farms that are actually scattered all over the world in a high-powered network, to interpret all this data from a huge particle accelerator buried under Switzerland. And he's trying to understand what they're searching for. I mean, they're searching for particles, right? The Higgs boson was one of the important ones that they hope to discover, and they've claimed that they have discovered it, though there are certain issues, as we'll see. And what he discovers there is a kind of bizarre circular logic, because the question becomes, how can we test whether a theoretical model correctly predicts observations when the model is already baked into the design of the instrument that produces the image of what is observed? Right? Because in order to interpret all the data, which is light that's been digitized in this particle collider, there's so much data produced that they have to select and filter the data that they think is relevant based on the theory that they have of what sort of particles they're going to find when these collisions happen. And so the vast majority of the data is ignored so they can look for what they already expect to find. And of course, they gradually adjust how they filter to search for a kind of signal in the noise. But the point is, the Large Hadron Collider is, it's often analogized to a kind of microscope, but it's not, that's a very stretched analogy. It's not a normal optical instrument where, a human being can look down a tube through a lens to see something magnified and have that sense of, sensory disclosure of something empirically given in our experience. When it comes to a particle collider or even a space telescope, these are not normal optical instruments. We're not really seeing through them. We're seeing with them. And so our vision is quite mediated, right? And quite really thrown out of proportion from what our normal human senses are used to dealing with. And so, there's a weird circular logic going on here. And physicists themselves have been critical of this. Michael Disney is one who Ekeberg mentions, and he looks at the Big Bang model, the lambda CDM model of, it's really a model of models of inflation and dark energy and dark matter and all these different elements that are, jerry-rigged together to explain a very small number of actual data points. And Michael Disney's point is that there are so many free parameters in the model that can be adjusted that it becomes difficult to see how this Big Bang model could ever be proven wrong, because every new observation that doesn't fit the existing model can just be brought into the model by adjusting those parts of the free parameters of the model. Right? And so, for example, when the rotational velocity of stars around the center of galaxies was measured, it became apparent that stars towards the edge of galaxies were moving far faster than they should if Einstein's general relativity theory was to be viewed as correct. And so the observation strayed from the prediction that Einstein's equations would have given, and so they had to make a decision. And what physicists decided to do was invent a bunch of missing mass called dark matter. And, in a similar way, whenever we observe something new that doesn't fit the existing model, we can just sort of tinker with the free parameters to bring it back into alignment. This is not unlike what the pre-Copernican astronomers, like Ptolemy, were up to with their epicycles, right? In an attempt to save the appearance of the geocentric vault of heaven, where it seemed like, planets would wander in these retrograde motions. Ptolemy came up with a geometric model of circles within circles, and every time an observation didn't quite fit with the model, he would just add another epicycle to the model to account for that erratic motion. Ekeberg also mentions Nancy Cartwright, the philosopher of science, and this important distinction that she makes between phenomenological description and theoretical explanation. And Cartwright's a kind of positivist, and she wants to bring science back to empirical reality. And she's worried that theoretical physics, and the paradigm case here would be something like string theory, has strayed so far from empirical reality into this sort of quest after mathematical unity that there's no longer any way to distinguish that quest from, metaphysics, because the mathematics of string theory are so far detached from anything that we could ever hope to measure. I mean, there's some estimates that you would need a particle accelerator like 1,000 times more powerful than the LHC to test string theory, and that's just not possible. The limits of that scientific theory are actually just funding, right? And so what do we do with string theory if it's totally detached from any empirical test? Can physics really advance in that direction? And so Cartwright wants to call science back to the phenomenology of the sensory world and its extensions, but how far can we extend our senses, right? And the space telescopes and the particle colliders are certainly telling us something about the world, but the worry here for Cartwright, for Ekeberg, is that we've lost all sense of proportion, and that the instruments are not actually producing meaningful data for us anymore, because the instruments require such fine-tuning, which presupposes an elaborate theoretical construct, that the only thing we could ever find or discover as a result of using these instruments would be a reconfirmation of the very theory we used to design them. So in some ways, Ekeberg is inviting us back to metaphysical square one. And, here I think is where Whitehead can pick up the baton and allow us to reimagine what it means to do science and, what it means to do measurement. And originally, to make measurements of nature, you need a ruler, you need a clock or their equivalents. And we easily forget that, the geometry, whatever geometry we use, Euclidean or non, it's ultimately making reference back to our bodies, to our embodied experience. And, any measurement we make presupposes what Whitehead calls a geometrical strain. And a strain is a feeling in our bodies. And so rather than allowing mathematics to become this free-floating, disembodied abstraction, Whitehead really does want to root it back in our feelings. And yeah, they might sometimes be conceptual feelings, but they're still feelings, right? And Whitehead wants to give the math, because he is a mathematician, right? And he does want to pursue a kind of unity. And Whitehead does have a theology, a process theology, but a theology nonetheless. And so in some ways, he's guilty of what Ekeberg is pointing out. If indeed that is something to be guilty of, it may just be that rather than getting rid of God altogether, we need a new concept of God, like the way that Spinoza reimagined the nature of God in univocal terms rather than the equivocating like Descartes did, saying divine substance and creaturely substance are of entirely different kinds. Spinoza just says, no, there's one kind of substance. And so if substance is that which requires nothing but itself in order to exist, then really there is only that substance, and it's God or nature. Whitehead does a similar move as Spinoza, but there are certain subtle differences that we will unpack as we go through this semester. I mean, in short, Whitehead is a pluralist instead of a monist like Spinoza. You could say Spinoza offered a kind of holism, but it was a kind of reductive holism. He reduced the parts to the whole, to a finished whole. And Whitehead really wants to move us away from this idea of finished or fixed substance toward creativity, toward process. And so, Whitehead would want to affirm the wholeness of the world, of the universe, and its inseparability from the divine, but he would also want to affirm oneness in a distinct sense as each of the many, which each is itself a one, right? There's a definite and indefinite article because there's one and many ones. And Whitehead wants to make sure no one gets left out, basically. And, Spinoza's monism would do that too by talking about every finite creature as a mode of the infinite divine substance, a modification of it, as it were. But Whitehead wants to give more creative individuality to his creatures and not just let them be appearances, ultimately. A mode for Spinoza is just, it's not really there. It's just, we see modes because we're kind of confused because of our sensory experience and our emotion. Really, it's all just God. And Whitehead wouldn't disagree that God is all in all, but he would want to grant individual creatures self-creativity, that each creature is a causa sui, right? Or is self-creating rather than just being a modification of the one self-creating being. All right, that's all for now. I look forward to your questions and contributions in the discussion forum.